evolutionary history of humans can be illustrated on a tree. Branches that don't reach the top represent extinct failed species of hominin, while other branches represent species which flourished and eventually evolved into the present-day modern human.
Diet has long been implicated as a driving force in human evolution. Changes in the type of food consumed and the manner in which it was procured have been linked with increased brain power and the emergence of bipedalism. One of the most reliable indicators for early hominid diet are teeth. Teeth are easily preserved and can be utilised in a number of ways, one of which includes microwear. Microwear describes a study of the microscopic scratches and pits left on a tooth surface by different foods. Tough foods, such as insects and leaves, are sheared through the sharp crests of the incisors and canines, whereas hard brittle foods such as seeds and nuts are ground down through the planar surfaces of the molars. The other indicator derived from teeth are stable carbon isotopes. The relative proportion of C3 and C4 vegetation in an animal's diet can be determined by analysing its tooth enamel using stable isotope mass spectrometry.
With this in mind, we begin our investigation around 4.4 million years ago, with the first known hominin from fossil records and debatably the last common ancestor of both primates and man, Ardipithicus ramidus. Ramidus exhibits similar morphological features to the modern chimp, such as long curving fingers, which, when combined with its more rigid legs and feet, suggests it was both a specialised tree climber and could also walk upright. Studies of tooth microwear done by a team of scientists led by Professor White of the University of California suggest they ate large amounts of fruit, nuts and leaves. Furthermore, stable carbon isotopes suggest that they ate woodland rather than grassland plants, which indicates that they resided in and therefore evolved from a forest environment.
The evolution of humans started out relatively slowly, due to little change in diet and stability of the climate. It wasn't until the appearance of the first species of a new genus, Australopithecus afarensis, around 3.5 million years ago, that major hominin diversification commenced. Afarensis had evolved a cone-shaped rib cage, meaning it had a large belly and long digestive tract, which implies a low-quality, large bulk diet. Scientists found that afarensis had increased jaw strength, which implies it ate harder and more abrasive foods. It is unknown whether this adaptation was motivated by a change in environment, or perhaps afarensis was just filling a dietary niche to reduce competition.
From afarensis evolved Australopithecus africanus, and debatably from them, Paranthropus robustus. These species occupied an environment in South Africa which, due to climate change, was transitioning from a woodland into a savanna grassland environment. The dental microwear of these two species has been a very useful tool for distinguishing among their diets, which shows quite a lot of overlap. Due to dental analysis, we know Africanus ate bigger and more abrasive foods. However, its microwear does not reflect the classic hard object diet. Therefore, and very importantly, it did not become a specialized hard object feeder, but rather had a more varied diet. Paranthropus robustus had a very strong jaw with powerful teeth, which show hard object microwear, suggesting it ate large amounts of tough vegetation and also hard foods like seeds, nuts and roots. In short, robustus could eat more of the tough, fibrous foods that Africanus could only access with hammerstones. This may have contributed to the eventual extinction of Africanus.
From the genus Australopithecus evolved the genus Homo, which showed an increase in brain power, likely due to improved diet. From the analysis of stable isotopes and trace elements, it's known that early Homo didn't consume more animal food than Africanus. Therefore, the primary dietary difference may not have been quality but quantity. Stone tools may have been the key difference, allowing early Homo to smash bones to extract the marrow within. Homo habilis lived in a predominantly grassland environment. The climate was becoming colder and drier, which may have been the impetus for new feeding strategies. Habilis, or handyman, was the first of our ancestors to make use of specialised tools, such as sharp stone flakes. These stone flakes were more advanced than any tools previously used, allowed for scavenging. They gave habilis the edge it needed to prosper in environments previously thought too hostile.
Homo erectus may have evolved from habilis and is believed to have been the first hominid to leave Africa. Around 700,000 years ago, there was a significant increase in large land animals in Europe as they spread from their home. It's believed that erectus followed these animals as they radiated from Africa. Teeth microwear studies indicated harsh wear patterns typical of meat-eating animals. Animal protein was more important now more than ever.
Oh, hello there. You just caught me practicing my spear lunges. Heidelbergensis lived at the time of the oldest definite control of fire and use of wooden spears. It was also the first hominin to work in cooperative groups which routinely hunted and systematically butchered large animals.
By 300,000 years ago, some of the populations had begun the evolutionary transition that would end up with Neanderthals and other archaic humans. Homo neanderthalensis made and used a diverse set of sophisticated tools, controlled fire, lived in shelters, were skilled hunters of large animals, and also ate plant food. One of the most important Neanderthal sites in northwest Europe is known as Le Cote de Saint-Brelade. At this time, the climate became colder and the landscape became more favourable and fertile for herd animals. The excavation site was found to have large piles of mammoth bones, which appeared to have been intentionally stampeded over the cliff and butchered. This had never been done before. Another Neanderthal site is in Gibraltar, known as Gorham's Cave.
Many charred muscle shells have been found there, indicating that Neanderthals harvested, cooked and ate them.
Rather horrifically, at a cave site in southern France known as Moulin-Garcy, there was evidence of cannibalism. There were 6 butchered carcasses of Neanderthals among those of red deer and goat. Their bones contained cut marks where a shoulder had been severed from the torso. An Achilles tendon had been sliced through. A tongue had been cut out and the thigh bone had been smashed to obtain the marrow within. This efficient job of butchery was most likely instigated by hunger, in which the group seemed highly unlikely to have died natural deaths.
The first widespread use of cooking fires coincided with the appearance of Homo sapiens. By now, the diet of hominins consisted of meat, fish, fruits and vegetables. Their jaws were also less heavily developed and had smaller teeth, with a no turning back now reliance on specialised tools including fish hooks and projectile weapons, such as spears, bows and arrows. This innovation allowed them to become even more successful, with the possibility of now being able to hunt smaller game such as rabbits.
Within just the past 12,000 years, our species made the transition to producing food and changing our surroundings. First, they established small villages. This agricultural revolution transformed Earth's natural landscape, first locally, then globally. Humans invested more time in producing food. They settled down. Villages became towns, and towns became cities. As more food became available, the human population increased dramatically.
Through the culmination of innovations achieved by our ancestors in order to procure food and avail of any and every possible food source, we have moved from a primitive live fast and die young strategy to a live slow and grow old strategy. This has undoubtedly helped make humans one of the most successful organisms on the planet today.